Hi, everybody. Welcome to Altinity Office Hours. We do have some topics that we wanted to go over. The first thing I'd like to dive into is just talk a little bit about the ClickHouse operator, um, for which is really popular. It's the most common way that people run ClickHouse on Kubernetes. So the Altinity operator automates that. It allows you to set up ClickHouse clusters, including replication with just a little bit of YAML. I can usually do it in about 12 inches. That includes storage and Zookeeper. One of the things that is particularly particularly interesting is that, and is big news for the operators, two things I'd like to mention. One is support for ClickHouse Keeper. So people who are using the operator right now probably know that as of the 0.23 release of ClickHouse, we introduced support for managing ClickHouse Keeper. Previously, you had to set it up yourself, using a script or using a YAML manifest file, or you use Zookeeper. We don't manage Zookeeper as a resource. That's the reason for that is that over time, the sort of big picture is that ClickHouse is moving away from use of Zookeeper and instead using the built-in Keeper implementation, which is really a C++ re-implementation of the Zookeeper protocol. So so that so we've begun to manage that as of 0.23. But if you are using the operator right now, we strongly, strongly, strongly recommend that you use 0.24. That's the latest version of the operator. And the reason for this is that we had an initial implementation that was put in with help from some of the folks in the community, and it didn't fully implement clustering. So obviously, when your keepers are pretty important, you don't want them to die. Or if one of them dies, you want the others to take over. This is important to get right. And as we sort of got into the clustering, it became apparent that the way that we had thought it through was, or not thought it through, the case may be, was not quite there. So we, in version 24, there's a new implementation. The problem is that there's not like a simple upgrade from 0.23 to 0.24. So if you are using CHK resources, I strongly recommend that you want to be on 0.24. The other bit of news about the ClickHouse operator is that once you're on 0.24, you want to be on the latest version, which is 0.24.4. Why is that? Well, it turns out that uh, you may have read this in the news, that DeepSeek, who's been in the news for a lot of other reasons, also made the news because they had a completely exposed ClickHouse. Uh, I think they were running on Docker or something like that. So anyway, the ClickHouse team, this is one of the reasons why people know what DeepSeek is doing and can, because they could read the logs just by logging into this unprotected ClickHouse instance. So the ClickHouse team, core team saw this. They rightly said, hey, this has got to stop. They put a tweak in for the, uh, basically for uh, to solve this issue. The problem is that that tweak broke some of the stuff inside the ClickHouse operator. So we put a fix in 0.24, which it corrects it. So this, if you look here, is uh, it was a fix in the entry endpoint. It basically affected the network access to ClickHouse, so it could cause clusters not to work. So, and you have to do if you apply this fix, it isn't a resource change or anything like that. It's really simple to apply when you upgrade the operator. You'll have to do a restart of your pods, but that's it, and that will take care of this problem. So that's kind of recent news on the operator. In fact, we have a nice blog article on it, which I will share, which shares the full story. Let me just get that up. Yeah, so if you want to get the full details, uh, which was it basically affected security of the default user and its ability to listen on networks other than localhost, as I recall. So anyway, here we go. If you're an Altinity.cloud user, you don't have to worry about this. We configure Altinity.cloud differently, so this problem does not come up. But for open source, where we saw it was folks using open source hit this. So now corrected. So that is, and what I'll do is I'll post the link to this in the chat. Let me just do that so that anybody who's interested can use it. I'll put that in the chat and then we can move on. Because the next thing is we want to talk about the latest Altinity stable release. If there are any questions about the operator, feel free to unmute and ask, or just type them into the meeting chat, and we will answer them. So the next bit of news out of the development, out of the engineering labs, is we now have a stable build for ClickHouse 24.8, and that was released in August. It, as usual, went through a baking period of ensuring that things were stable, waiting for patches to arrive from upstream, as well as for us to be able to backport fixes that we have. This is a major release. I do recommend it for upgrades. Some of the key things, as usual, in fact, let me post the information. That's in the chat. You can see the link to the docs. There are a bunch of changes in this. One of the biggest ones that you'll need to be aware of is that ClickHouse now enables the analyzer, which is what that really means is the new query planner. And this, in many cases, significantly boosts performance, but there are cases where you have legacy queries, by which I mean a query written before 24.3, which may be affected by the fact that the analyzer is now turned on by default. Those may go slower. And there's a way to turn it off. You can set enable analyzer equals 0 till you can work out what happened. In our own case, when this setting was changed, we ended up having to look very carefully at a number of tests because it did change behaviors. And there are reported issues here with the analyzer. This is a net beneficial change, but as with any major change, particularly to things sensitive parts of the server like the query pipeline, there are going to be some bumps, and so we're still seeing those. I think those are or you can read about the other ones. There are some backwards incompatible changes, known issues, install, and then new features. And there's definitely a lot of them. I don't know, Mikhail, you're on the call. Do you want to comment on some of your favorites out of 24.8? I just looking at it, I think that some of the join improvements look pretty tasty, but you may have others that are your favorites.
Yeah, actually, there are quite a few smaller things, and also few major. Let me also open the doc. I'll just
Yeah, just to remind yourself of everything on the long
yeah.
list.
Exactly.
And
Yeah.
someone, Patrick, be ready. I'm going to ask you the same question. What are your favorites here? So
What did
you
I
have
do
been
wrong?
warned.
Yeah. So actually, like that async loading, I guess it's one of a big change which happened, which was enabled there in like by default in 24.8. It actually can be really saving a lot of people who has high number of tables. And right now, sometimes like we see those situations if when some people they create like thousands of tables. And the startup time for the ClickHouse currently, or like before that release, was minutes, or sometimes even like half an hour, or even an hour. So like you restart ClickHouse for, I don't know, doing some setting change, and you need to wait for 1 hour till it become back responsible. With the async loading, that process get get much smoother. So you can just now enable that, or it's actually enabled by default, so you can keep it enabled. And in that case, the loading, so all the objects will be still loaded, but it is not blocking from for serving your queries. And you can ask what will happen if you try to access the objects which are not yet started. Actually, at the moment of start, after that change, ClickHouse built a queue of all the objects which need to be started, and eventually it will be starting all those objects. But if you'll query one of them, so if you query one of the tables which is not ready yet, ClickHouse will just shift the priorities. So it will just prioritize it and will try to load that immediately for you. So this way you can so after we restart, you can have some small delays when accessing some of the tables, but the restart itself will be almost instant. So that is a big change which will make
So
lives easier
just
for a lot of people. Yeah.
just to be clear, so if I have an application and it connects to a table that's not yet loaded, that won't fail.
That won't fail. Yeah, yeah.
It'll just
That's
reorder it
yeah.
to pull it in, and
So
I'll just
you
kind
will
of
have a
hang for a
small
bit.
it will have a small
Yeah,
delay. So like that,
yeah.
like it will just will just shift the priorities to make it loaded quicker, and while after that it will read the metadata from the disk, and after that will continue execution of a query. So that's pretty cool.
That is way cool because that means that because we normally have our standard support response to, somebody loading like 5,000 tables was don't do that. Now at least
Yeah, it's still maybe
we
it's still
still
not the greatest
that's
That
idea, but
remains.
it
yeah,
doesn't
but
we're still going to
uh,
say that, but maybe
yeah.
just a little less urgently because your stuff isn't going to break. Okay, so this definitely goes on the favorites list. What
Um,
any other highlights?
well, let me check. Actually, about like there are few smaller things about the SQL usability. It's funny, but those things like those small things they make life sometimes much better. So, for example, there is a very small improvement which is probably you Robert you laughed at. It's you can now type alter table drop detached partition all. So just don't list all of them just one by one,
Yeah,
just all of them. And
yeah.
it's like and like just clean the trash bin. Like
I'm
it's
Yeah.
thinking that might be Anselmo, one of Anselmo's
yeah.
favorite
Yeah,
improvements
actually
as well.
no, because I will check thoroughly each but detached part to see if I can drop
Yeah,
them and not just drop a
Yeah, but
bunch.
you know, like you can just
yeah,
first check, ensure that all of them are
Yeah,
old, and no,
yeah.
and
nothing
then just
is, yeah, and
After
after
blow it
that,
that,
away.
yes,
drop
it's
all.
very handy. Yeah, it's
Yeah.
very handy.
It Anselmo, do you have any in 24.8 anything that pops out for you as stuff that you think is especially
Uh,
lovely?
yes, it's a recurrent question from customers. It's about joining on inequalities. Now it's possible.
Yes.
Although we have
Yeah.
to explicitly enable it, and the qualify clause for window functions. Actually, we have some customers request for us to improve our guidelines on usage of window functions because our last post in the blog is back in 2021, and this is one that actually the qualify clause is one of the reasons. It's not easy to understand and how to use it. So that's one of
It,
my favorites as well.
Patrick, anything from your side, stuff that you would like to mention at this point? I think you're muted.
The issue that you mentioned with DeepSeek that caused me a little bit of confusion for a few days, and I'm sure a lot of people ran into that. If they didn't update the actual operator, you would get an error saying that there was no default user password set or anything like that. And then I updated it, and because I was working on a script, I had a customer ask if they could have a script that would take backups done on one cluster and restore them on another cluster. And
Right.
after I fixed that issue, I was able to finish the script. And so backups are particularly interesting to me.
Yeah, and just to be clear, that DeepSeek issue won't come up in 24.8 because it predates the fix. So
but at the same
the
time, the backport for that was pushed down. So
oh
Yeah.
if you use 24.8.14 and newer, actually
yeah
like so it will just forbids for the Docker containers. It forbids to use the network for
yeah
the passportless default user. So it was not yet in the Altinity stable, but the next
it'll be
Altinity
there.
stable it will be right.
Yeah.
Yeah, you have been warned.
Yeah.
So
Mhm.
just upgrade your operator and there'll be no problem. Great.
All
Yeah, and about actually, like I'm just looking on the screen right now. You have like about recursive CT. One of the
Yeah.
engineers
Mhm.
in Altinity, Boris, he using that feature, he created the parser of the binary data.
Yeah.
It's really so insane. So
Yeah, he loves
Yeah.
that.
yeah,
Yeah.
it's really like it's you now can really create some recursive programming like some
Yeah.
complex really write
Yeah,
some very complex stuff with ClickHouse using that
indeed.
feature. It's not like perfect, like it will be not as fast as, I don't know if you can write that in some programming language, because SQL is not for that, but it's really make really wow impression. Yeah, so this one is cool.
Yeah, so there's actually another cool thing that's come up is we now have a cluster maintenance cookbook. We had one for upgrades, which was written by Dima Borovtsov. We now have another one that's written by Diego Nieto and Tatiana Saltikova. Let me see if I've got a copy of it. I'll just bring it up from my mailbox. Give me 1 second here. Uh, this is pretty cool. It doesn't look like it's arrived yet. But what this does is talks about all the things that we've learned about performance. You can, up here, I've got it, just a second. Let me bring it up and you can, uh, let me show you what it looks like. Here we go. Okay. And what you saw was I fetched it off the site in real time. All you have to do is type in your name or a pseudonym like ABC and provide an email link and you get a copy. But here it is, very tastefully designed, and basically covers all kinds of issues that we've seen over the course of supporting ClickHouse. So there's a lot of good information in here, uh, ranging from, sort of basic monitoring to, tricks for diagnosing problems, so on and so forth. So definitely urge you to check that out. I think at this point, we do have some questions queued up. So DeepSeek and ClickHouse, security discussion. So one of I don't know about you guys, but when I saw that, when heard that the DeepSeek had left this, had left this server unprotected, I was kind of petrified because I thought, oh my God, there's, like they found a new way that ClickHouse uh, can be data can be exposed, but it turned out they really didn't. Uh, if I understood it correctly, what they did was they had a Docker container which they basically ran with a direct connection to the internet. There was no password for the default user. There were no certificates. I mean, it was just it wasn't even using HTTPS. They, you know, and of course they didn't put any sort of guards up, like security groups uh, and cloud instances. Everything you could possibly leave open, they left open. So for people, for example, who are using Altinity.cloud, what happened to them will not happen to you because we don't let you do it. And I think that's true of every other vendor that you work with ClickHouse. That said, it did expose this issue, which, as we said, the ClickHouse team rightfully fixed and quickly. Did trigger a side effect for the operator, which we've also fixed quickly. And I I don't know, guys. Do you have any comments on that? Sort of any broader lessons from this, or other things that are takeaways from that security problem?
Yeah, it made me think about old bugs on operating systems. Most Linux distributions in the past used to install by default RPC bind and NFS stuff. and by default they were quite unsecure.
Yeah.
And basically, if the default distribution it don't enforces some security rules, the user will end up falling into that kind of situation, being exposed or having a data breach. It was kind of a childish thing. When you start to play with ClickHouse, generally people recommend to use the Docker image, and the Docker image by default it wasn't actually enforcing anything. So it's not even relaxing
Yeah.
security. It's basically no security at all. And exposing
Right.
that to the internet is is very dangerous. I don't know the reason for that,
Yeah.
but I think it's kind of risky anyway. If you have sensitive data on a database, it's a bad idea to do that.
Yeah. Yeah. I
Yeah,
think.
and actually for me,
Yeah.
it's
I'll
like
go. Go ahead,
mostly it's
Misha.
mostly about like those how it's like those funny laws. Like if something may break, it will break. Like so, it's actually it's about here like the default development. It was just keeping the like here is we are user friendly. So like you have you deploy ClickHouse and that ClickHouse is ready for use. Like you don't even need to type the password. But actually, it was well the next step if you want to go production. Yeah, you need to think about that, how to make the password happen. Yeah, and yeah. Somebody that didn't think about that, and
Yeah.
but you know they did some advertisement for ClickHouse now. This
Yeah. Yeah.
Yeah. If you want to, if you want to look for your database to hack, here's another one to add to your list. After you've done searching for all the
Mhm.
MongoDB and MySQL databases that are unprotected on the internet.
Just a T-shirt that says "Principle of Least Privilege" and just wear it.
Yeah. So yeah, that was definitely a learning experience. I was glad as I said, I was glad to see that they did it in such, it was so basic that it was pretty easy to you know,
Yeah.
pretty easy to fix.
Five
We
minutes
haven't,
in a call, we could explain then to how to avoid that at all.
yeah. So hey, we have another question which came up, and it is specifically, can we go from somebody, I asked this question, can we go from version 21 of ClickHouse to version 24 directly, both in cluster and standalone Docker environments? That was a submitted question. Does any opinions on that?
And well, we were discussing that today actually, because we have some customers that are falls into that situation, and it may be possible if you're not using anything too advanced, or especially tracking states for UDs, some strings, that sort of thing, because it's hard to predict there. But it's risky. So the better pathway here would be to upgrade to like 22.8 or 23.8 before going to 24.3 or 24.8. Changes in the representation of data on disk. Also, if you're using ordinary database that requires extra steps, and basically if following the upgrade cookbook here, we'll test it before going to prod, so that will avoid a lot of headaches. One thing that may be necessary to do is to disable compression of primary key and marks. Also, there's another setting, which is, let me see, I took note of that. Ratio of defaults for sparse serialization have to be turned to 1 because it changes between versions. It can cause some failures. Then I leave to Misha
Yeah,
to
and
complement
actually in
that.
very short, you can like if the upgrade itself, so if you just stop the world, upgrade everything and start a world, it will work actually. So now
Yeah.
there is no
Yeah.
incompatibility between like in binary like the new version, so you can always read the stuff written by the old versions. But
Yeah.
once you do that, you have no way back. If you want to preserve some the way back, just to have like so after the new version will start to mess up with data. Like after that, immediately after a few minutes, like it will become incompatible with the old one.
Right.
Yeah, just a
So you
single
cannot
merge can
you
break
just
things up.
you
Yeah.
cannot like the rollback will not be possible.
There's
So like
no
this.
way back.
Yeah, so
You're
actually, you know, you can it could be better maybe to if you really need to test that without just to test that first as usual on staging on QA environments, like just to ensure that everything works. You don't want to go back, and if you want to preserve the way to go back, then you maybe need to, or you want to do that with smoother upgrades, like when you do upgrade of a single replica, for example, or something like that. In that case, for sure, you'll need to use some intermediate versions.
Yeah, and if I could just put in an ad here from our, from our sponsor, we have an upgrade cookbook, and I'm showing it right here. You can get it off the Altinity's website. It's written by Dima Borovtsov. Has a bunch of just, sort of learnings about how to upgrade ClickHouse effectively. And Dima does have some reason to claim expertise in this. He finished in December helping one of our customers do an upgrade that covered 1,000 ClickHouse servers, where they went actually from version 19 to, I think, 24.3. Yeah, it was so that's like a 4-year jump, and they managed to do it successfully. It took months, because they were really careful, and they basically are up and running with there were no major problems. So it
By the way,
definitely can be
does
done.
it also include the upgrade of the operator? Actually,
Yeah,
I just had exactly that question today. Like the guys were asking like about do you have a nice material about the upgrades of ClickHouse plus ClickHouse operator? Yeah, so
yeah, that's, what, that's something we need to do a better job at. I can tell you one of the places where the ClickHouse operator is tricky to upgrade is if you're using Helm. I'm kind of I didn't used to be this way, but I really like Helm. It's super convenient. But one of the problems that Helm doesn't deal with is custom resource definitions. And these are the things that define things like the CHI resource and the CHK resource. Changes to the Helm doesn't deal with those changes. And there's internal reasons. And I heard the reason a while back, like a year ago, and I promptly forgot it because I don't know the code that well in Helm. But basically what you have to do is Helm will happily upgrade the pod, but you actually have to manually upgrade the CRDs. Another thing about the CRDs is they are global. This is something that I think Kubernetes is going to fix, but basically when you upgrade the CRD, it changes it across the entire Kubernetes cluster. So if you're running multiple operators, they all are going to see the new CRD. So you got to be kind of careful about this.
That's
What I did.
we should add that to the document. Maybe even to the same document. Yeah, like that could be cool. Yeah.
We need a mini upgrade. So Patrick, you were going to say something?
Yeah, what I did, I had a Helm set up for my cluster, and what I did was I edited the deployment for the actual operator and bumped the version of the container being used. I don't know if that's, I just wanted to upgrade it, but maybe I should have done it via values. Either way, I'm not certain of. That's probably something to document and get it in there. Get it in the upgrade.
There is documentation, but you have to do it very carefully, and it's a little bit non-intuitive. Like this thing about Helm and CRDs, that's definitely so. And if you have questions about that for anybody who's using the operator, you can always join our Slack channel. This is the kind of thing where we'd rather have you come and ask us. There's the Altinity public Slack. It's really easy to access. I'll type the address down here, HTTPS. I just throwing it in the chat. It's a really simple link. It automatically forwards you to the invite, and then you just pop up inside our Slack. Ask questions about that. We don't, if you're an open source user, definitely better to ask than to upgrade and accidentally screw your system up and have downtime. Let's see. What other questions do we have? Hey, here's one that came up. This is a question that came from Reddit. What's the best way to do bulk inserts? Any thoughts on that from the assembled masses?
Do it. Just do it.
Big parts.
In MySQL, what I would do is I would just write the code. If I had a bunch of rows to insert, I'd build up a query with the bulk insert because, same situation there. But,
Yeah.
I'm guessing the question is for application side, right?
Well, I have an approach for that. Not sure if this is the best, but it works for me. It also implies that you know your data set, and it works for ETLs. Never test that for Kafka or other ways to get data into ClickHouse, especially with streaming engines. Based on the amount of run available on my server, I will check how many parallel inserts will do best, but that implies knowing the average size of per row to check if the default 1 million rows for ClickHouse will work fine. And I was doing a test on some log data. Each record was around what the default actually works best, which is 256 bytes per row. Basically, if you divide the mean insert block size bytes by the default block size, you get that number. So tuning those to avoid creating too many parts, that sort of thing. We generally recommend to customers to use some atomicity and idempotency in inserts because they can fail, and if you need to repeat them, then it's a lot of trouble if you're not leveraging like the duplicate token or other deduplication techniques and replace and merge tree. So for me, what works is to find out how many inserts I want to do at once. If I have a single server, then it's easy to calculate. If I have 10 inserts and 32 gigabytes of RAM, and then I can go up to like 16 with like up to 1 gigabyte per insert.
Mm-hmm.
Then I divide by the average row size, get the number of rows per batch, tune those two settings to create a single part. But in experience, I never went up to 1 gigabyte. Above 500 megabytes, in my cases, they were timing out too often. So that's also another concern.
Yeah, and actually, like I guess the like you can see like you can hear very different answers for different people. So it's actually like the question is so broad that it can be like really millions of answers depending on the details. So actually, where you have original data, what is your framework which you're using? What is what is the level of concurrency? What is it cluster or not cluster and so on. There are a lot of small details which can like all together can be impacting that, like which answer is the best here. But in general there is a format which you need to accept. There is a blocks which ClickHouse will form. There is a table schema which will impact the partitioning and eventually sharding. So lot of moving parts there. And if you use some framework, I don't know, like if you use pipe like Python, Golang or whatever, they use you can use like sometimes they especially in some universal frameworks like JDBC, by default they expose the interface for inserting data row by row. ClickHouse doesn't really like that, so we really want to have the data in bulks. There's 4 maybe bigger blocks, and check the documentation of your library if you use that, which how to do that, because every library and every programming language allows that, but allows that a bit differently. Yeah,
I'm sort of a post SQL guy, so or sort of a post library guy. I like to try and keep stuff off the client. So my favorite, hands down, is put the data in S3 and suck it in from there. Partly because because the thing is, I see a lot of times where people are actually routing it through the client, which means they're going somewhere else. They may have to pay egress if they don't do it right. But ClickHouse rips on S3. And yes, you got to consider the issues you were bringing up on Selmo about, hey, do you have enough memory? But you can use things like max insert threads. You can use S3 cluster. If you want to load like 50 million rows a second, if you have a big enough machine, you can definitely do it on from S3.
And one often overlooked factor is how wide the table is. If you have 1,000 columns, that will be a very close to a nightmare.
Still possible,
unless you have like 2 terabytes of run to deal with, then maybe
Yeah.
easy,
But
but
you'll need to be you'll
You'll
need
need
to learn a bit a bit of
yeah,
ClickHouse
but of the
inside. So,
internals, yes.
yeah.
you'll need to be thoughtful. And in fact, what you can do is if you really had to do that, if you use the operator, you can scale the instances up while you're doing while you're doing ingest and then scale them back down, for just normal
One flow to go.
queries.
Yeah, yeah. Just to
Yeah.
use like more like instances with more RAM. But actually, it will be even just one funny thing that ClickHouse actually, because it's a columnar, and if you create a bigger rows if you have a wide rows and insert a lot of data, ClickHouse will immediately start to write a wide part format. So it means that every single column will be living in a separate file. And if you have a lot of columns, like thousands of them, ClickHouse will open thousands of files during your insert. And
Yeah.
ClickHouse also uses some fixed size buffers when it opens those files. So no matter if you want to write 1 byte in every file, but it will pre-allocate 2 megabytes
Mm-hmm.
per every file. And 2 megabytes multiplied by 1000, you can have really big numbers of memory usage. Yeah, so it's like like those
Yeah.
insights can be sometimes surprising. But like for example, there is a very simple workaround for that. You can just toggle ClickHouse to force it to use the compact file format. In that
Right.
case, all the columns are mixed together in one file.
I think that's a great example of how, when people sometimes ask what's the difference between Snowflake and ClickHouse. Snowflake, if you know SQL, you can get it to work. With ClickHouse, you have to know SQL and you sort of have to know what it's doing under the covers. So that's to get these, otherwise you run out of
Yeah,
memory, for example, the kind of things that Anselmo was describing or exhaust, you can exhaust inodes. You definitely have to be a little bit more, have more of an interest in the plumbing under the covers.
Yeah, so
indeed.
So,
it's actually it
yeah.
forces you to learn a lot of things, but at the same
Yeah.
time, if you're doing something, if you just follow there are very straightforward paths inside ClickHouse.
Yeah.
If you just go
Yep.
one simple road, it will
Yeah.
just rock solid. You don't need
Yeah.
to think. It just SQL
Yeah.
insert select everything
Yep.
works
Yeah.
as
It just
in
rips.
school
There's no,
books. Yeah.
nobody's faster.
Yeah, and
Speaking of complications, though, the next question was another Reddit question. Can you recommend star schema best practices in ClickHouse? This came off here. I've got any thoughts on that? This is kind of a fun one.
Well,
uh,
favor
So I just
yeah.
dictionaries instead of joins.
Good one. Hey,
Hmm.
Anselmo, for people who haven't heard of dictionaries, do you want to explain what they are? Because I remember when I first hit them, I thought, what the heck is this and why? What is a dictionary?
Well, dictionary in ClickHouse, as I understand, it's basically a way to look up a key pretty fast. By default, it
Yeah.
resides in memory. It's a specialized data structure for that, so you can look up a key and retrieve some attributes. It looks like a table, but it behaves like a key value storage
Yeah.
engine. Mhm. And the
Yeah.
fastest
So,
one, they go to memory. So if
yep.
Users
at
love
least
it.
if
Yeah.
yeah, one thing that I was discussing, I don't remember who these days, is if you have a complex key, for example, you need to search to look up a value by a complex key, three to or more columns. One good idea is to hash those 4 columns into a single integer value, so you can leverage like a hashed array or a hashed
Hmm.
for fast lookup. Complex key, it's slower as well. Sometimes we see some degradation in performance, and mainly caused by too long keys. I had one customer that decided to use 7 columns as a key for a dictionary. That was crazy.
Hmm. Yeah. 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 I didn't understand dictionaries, but the fact that you can join on them, they're kind of like they look like, they look like normal SQL joins. They're definitely the cat's
Hmm.
meow, especially if the table's not too big, because then you just have a
Hmm.
block of memory and it's always there. Any other hints on star schema best practices?
Yeah, actually, sometimes if you it's while talking about what star schema or snowflake schema, it's actually one of the questions here. Like maybe you can denormalize a bit. Like it's also quite often pops up. So instead of one option is just really have like that fact table in the middle and have those dimensions around, like in the classical star schema, and those dimensions inside ClickHouse. It's better if they live in the dictionary. If you can do that, you're really great. But sometimes if the you can just put the undicted value inside the fact table itself. So it is if the data is immutable and if you need to filter that by that, it can be sometimes better. So it means that you will lose the possibility to change that later on as every time if you don't denormalize. So it means that, but in case if the data like that relation between ID of some dimension and the actual value of that or some attributes of that does not change between the moment when you insert the data till the moment when you select the data, then it can be also an interesting option. So just having wider table itself with those attributes denormalized inside ClickHouse can also work in many cases, but it depends on the usually the main showstopper if the attribute tends to change in time. So it means that between the moment when you insert and the moment when you'll be selecting the data, the attribute will change. In that case, you cannot do that.
Yeah, also the size of the dimension played a factor here. If you have too many values in a dimension, you move that to a flat table, you will have to read them all the time from the disk.
Yeah.
Whereas on the dictionary, you can tune the dictionary to be small enough to fit in memory, and that operation will be faster.
Yeah.
So
yeah. Okay. What about putting dimensions in things like a MySQL database? I've heard of people like particularly
you can put a dictionary on top of the MySQL source,
and you can put it exactly, and that also is a way of representing mutating, dimensions that mutate, because you can of course change them easily in MySQL or Postgres, but not so easily in ClickHouse. So good,
yeah,
definitely.
Those dictionaries they have a lot of different subvariants of that. So like in the simplest form, the dictionary will live, the whole dictionary will live inside ClickHouse memory, making them like rocket, like very very fast accessing that. But you can also use the cached layout, for example, for like if the dictionary is super huge and you cannot put everything inside the RAM, sometimes you can put the subset of that. I don't know, like we had some use cases, for example, then let's assume that we have a table with the events collected from @tech from a lot of users. And if you just check the cardinality of that users field, it's more than like several dozens of millions, like I don't know, 40 millions of users inside that table. So it means that, well, you will need to have like really gigabytes of data to put all the information about the users inside the dictionary. But at the same time, if you look on the usual amount of the active users, so you have like 40 millions of users in 3 months. But if you look in the scope of 1 hour or 10 minutes, the amount of the amount of active users will be always less than few 100,000. So actually, it's not always the same users, and some users say log in, some users log out, and you just never have the same all the huge set of the users active at the same time. So it means that you can, in those cases, you can sometimes use those dictionaries, like you can use cached dictionary, for example, that cached, like it can cache subset of the IDs. So you can cache, for example, I don't know, like 1 million users, and it will just fit in RAM of average machines. And if the new user will log in, the ClickHouse will be loading the data about those users from the backend. But that always, obviously, that's also limit you, that you cannot access the data for all users at the same time. So you can always access the data in the smaller time frames. But you can use that, for example, for enriched data or things like that.
Great. One last question that I have on my list, which is if you're new to ClickHouse, any tips? Like what is, like, just round robin, right? What is one thing you'd want to know about if we're using ClickHouse?
Oh, That's a classical
Maybe two.
article in our classical article in our knowledge base. How to pick up an order by.
Oh,
That's
do you
the
have a link for
first.
that? Do you have a link?
Uh,
I'll show. I'll since we're sharing.
yeah,
I'll.
yeah. Let me get it. And the
Yeah.
second one is don't think about partitioning as a way to optimize our queries. Think of the
Oh yeah, yeah. That I.
That is super cool. Like I guess like the users which start using ClickHouse, I guess issues with the primary key and the partitioning key is probably top one
Yes.
issues.
Yeah. So the
Also,
difference between sorting data within a partition versus breaking it up into partitions. And in
yeah.
fact, Misha, you did a talk, I think it was 2022 when things were
yeah,
opening up from COVID. There was a talk and that you did at the
yeah,
first ClickHouse meetup post COVID. That was in Amsterdam, and you were talking about exactly this issue about how to represent multi-tenant data, uh, and
yeah. It
you
was very,
sort
very,
it.
very yeah, like lightning talk, like very short one, but yeah,
Yeah,
but actually, I don't know. Like I probably can write a book about the funny problems which I don't know. Like for me, it's also one of the anti-patterns which some people do when they start using ClickHouse. Then they just do the big bang integration. And that
yeah,
is not something which you like. So just don't try to move all the tables. Just like like it's better to start with something small or actually with something big. Like take the biggest table and
right.
start playing with that ClickHouse. Learn how ClickHouse works. Learn how to do the things inside it, how to write the queries properly, and so on. Don't try to move 1 million tables inside that like instantly after that, because if you move instantly like 1 million tables, most probably in after a month you'll need to rewrite 1 million tables. And it's like if you start with one table, you will learn, you'll still need to redo that like 1 or 2 times, and after that you can bring the rest million of tables. Yeah.
Yeah, that I have two tips that I think I've seen, and not necessarily by being struck by these, but just seeing how many other people have been. One is test your data, kind of keying on what you have. There's people are always asking, and I think with goodwill, they want to know, hey, will this work in ClickHouse? And the answer is generally, well, it depends. How much data do you have? How many resources are you running? Are you in a cluster? And so the simplest thing to do, just load the data in and run it, and then ClickHouse gives you really great tools like the system.querylog to figure out what's going on. You can enable traces like the OTel trace log is kind of amazing for tracking query plans. So testing with real data is absolutely essential. I think the other thing, which is less obvious, but is kind of similar to the issue that Misha brought up with partitions versus order by, is to understand that ClickHouse is eventually consistent. And it's not just eventually consistent in the idea that, hey, if I insert data on one node in a replicated cluster, after a while it will show up in another node. That kind of eventually consistent, I think people kind of understand, but it's eventually consistent in the sense that ClickHouse tries not to ever make assumptions that require it to go check every single for example, to delete something or change data, you basically have to go check. If you want to do it consistently, you have to go check every node and put locks on it. ClickHouse just doesn't do that. Instead, what it does is it updates data a piece at a time, and so you see eventual consistency popping up in all kinds of different places, like the way results are come back to you. If you have a query that goes across many shards, you will see the effects of eventual consistency because ClickHouse doesn't, if it doesn't have to, ClickHouse will not order because ordering is expensive and requires like a sort in a single place. So ClickHouse doesn't do it because it would be slow. ClickHouse always chooses what's fast, and sometimes at the expense of making it hard, of violating conventional expectations about consistency of data. I don't know if you guys can explain that better, but it's one of these issues. If you kind of get your head around it, a lot of stuff in ClickHouse starts to make sense that doesn't make sense if you're just used to MySQL or Postgres.
Yeah, also I also like while you were talking, it reminded me like one of the like also top issues which newbies tries to face inside ClickHouse. So I have my ClickHouse. It has some data. What will be your first query you coming from MySQL, for example? What would be your first query which you'll type?
Select star
Start
from
from
X.
limit
Yeah,
something order by,
just forget
etc.
that. It's
Yeah.
not the query for
Yeah.
ClickHouse.
Yeah, that's right. Yeah, it's
No.
yeah, you always want to put a limit on things. You can do a select star to see to sample the data, but yeah,
Yeah.
ClickHouse it'll just get really, really quiet when you do that. So
Yeah, and especially if you
yeah,
just go also like if you come from MySQL, which you like you get used for doing queries, select star,
yeah,
order by
yeah,
something, limit
yeah,
even like that. The select star
yes,
from table, order by timestamp, limit
yeah,
one, and
yeah,
it works instantly inside MySQL because data is
right,
ordered by that field. But
right,
inside ClickHouse you type the same, and ClickHouse like just getting some crazy work like
yeah,
like
yeah,
hitting the server room. Yeah, and after you learn what's happening and how to do that properly, you just, ooh,
yeah.
what the hell, what did I
Hey,
do?
well, why in that particular
Yeah.
case, why does ClickHouse, so is it like doing, if you do it on a cluster, it doesn't know how to do a top N to,
Yeah, it actually depends. Like if the
yeah,
data is like usually if you create a good
yeah,
schema inside ClickHouse, you don't
yeah,
order by the timestamp. You order
right,
by something else. So
yeah,
so it means that to really order the data for by the timestamp,
yeah,
ClickHouse
you
will
have to,
do so.
it'll do a
What did
sort.
you ask? You ask all the columns, select
Yep,
star. You
yep,
asked like to order all of those
yeah,
like by the timestamp. So
yep,
ClickHouse will physically read those gigabytes,
yeah,
terabytes of data from a disk,
yeah,
order them inside the memory, and
yeah,
start streaming back your data to you. Like
yeah,
if you type limit one, well, it will
yeah,
stream only one row, but it can be like just it's very literal sometimes. Like
yep,
ClickHouse, like be careful. Like what you type is exactly what ClickHouse understands. If you typed like I want
yeah,
everything and sort it,
yeah,
it will read everything and sort it.
yep,
It's not something which you
yeah,
would expect.
yeah. I know top end queries are top end on sorted data is like
Yeah.
kind of the path to doom. Any other suggestions? Because we're kind of hitting the top of the hour. Any other final suggestions for new ClickHouse users?
I would
Make
I would
a lot
say
of
that the
fun.
oh sorry the just understanding parts.
Yeah,
ClickHouse, the way I was trying to explain it, I said somebody, I think it was to Anselmo the other day, I said ClickHouse is kind of, when you see a giant swarm of birds that are kind of flying through the sky in different shapes, you see that single shape, but the database is like all of the actual database is a composition of all of these parts. And if you understand that and how to work with that, and there's a lot in order to understand it fully and know how to work with parts, that's the most crucial thing I can think about with ClickHouse. And the training we've had here that I've had at ClickHouse has been really good, and you can sign up for it, and it covers
yeah,
that thing from the get-go.
absolutely, absolutely. Yeah, I think you're right, and it's the it is the unit of data in ClickHouse. It's the unit of transactions. ClickHouse will never show you a torn part. It won't show you a part while it's being written. Uh, yeah, and I think as you understand that, it it really helps you. So, okay, well, we're at the top of the hour. Thank you, everybody. Thank you, gents, for a really wonderful discussion. Thanks for the questions. Uh, this will be recorded. Anybody who signed up will see it. It'll also be out on our uh, uh, YouTube channel shortly. Thanks again, and we will see you all soon. And by the way, if you have more questions, come join our Slack. We're not hard to find, and we love talking about databases.